Hello and welcome to C++ Weekly. I'm your host, Jason Turner. Now, in this episode, I am going to cover something a little different. I have a custom build of the Compiler Explorer set up on my system. What I have done here is set up the Compiler Explorer with the LLVM C backend. So instead of compiling our code to machine code, say, for the x86, like we demonstrate in almost all of our examples on this show, I am compiling it to C. So this has some really fascinating stuff, and quite honestly, I don't actually have anything specific planned to show you. We're just going to mess around with it for a few minutes and see what we see. So we start out with this code that has some basic type defs and such set up. And I'm using a different virtual machine setup than I normally do, so hopefully everything is legible. I'm going to go ahead and up the font sizes just a little bit to make sure. We've got this code that is just, it's doing nothing. There's no main here. So let's make a main. And we have our main, and it is truly making C code. It is even passing our void here, which annoys me. And we can see the return 0 and the fact that this is a uint32t that is being returned. And that's really weird. I would expect it to be a signed integer, but this is what it's doing. So let's start pulling in some stuff and see what happens. Now this should be a string that easily fits within the small string optimization, and we are building with all optimizations turned on. So let's see what this function looks like. Like I said, I really didn't plan anything, so hopefully this gives us something cool. So we have our getString function, and it seems to be tagged with something telling us that is the C++11 ABI, and it is a function that takes void parameters, and it returns a struct of this type, which is basic string, and we can see kind of some of the name mangling being put in here. And it is setting up some of the values in the string, some memcopy, interesting things going on, and then returning struct return, which, where is that? That is defined here at the top. And since this is all strict C, it's having to put these things having to put all the variable declarations at the top of the function. And we see memcopy being defined here. There's not as much interesting things to look at. Maybe it was a little too complicated to pull in string. Let's look at something else. So we have our own struct. Now let's write a function that just simply returns this struct with its default initialization. Well, that's quite interesting. It is calling our struct unnamed 1, which I find fascinating because it is definitely named. Let's see if anything changes when we change the type of initialization. Nope, nothing changed there. But it is creating our struct and passing in these two values. So nothing surprising there, but we can also see that it has split out our constructor, unnamed 1, which this code is growing quite rapidly. So let's get our string code out of here so that we're not obfuscating what we actually want to look at too much. And here we go. We can see the constructor that it created for us. So it's returning a struct, has these two values, assigning them, and returning R. Now, granted, in a fully optimized thing, so most of this is going to go away if I do something like, we know that 12 is going to be returned from main. And in fact, we should be able to see that here. Yes, main is simply returning 12. So the compiler is still doing all of the optimization and constant folding and stuff that we had expected to do. But this is very interesting. It generates strict ANSI C, as far as I can tell. And this is LLVM-CBE, if you wanted to look it up. There are a few different forks of it. Honestly, I cannot remember which one I built here. But this looks like the kind of thing that we might be able to utilize to some extent to maybe get higher quality code compiled for the Commodore 64, like I've shown in the past, since there are C compilers for the Commodore 64, instead of doing the kind of static translation of x86 assembly to 6502 assembly, which was definitely a hack, but an awfully fun hack to implement. Be sure to subscribe, follow me on Twitter, and check out any of the links below.